Okay, so we're going to continue with chapter 3 estimation, and this will be the continuation to the previous video that I have shared with you in my YouTube channel. So please go through, for those who haven't gone through the video yet, so please watch that video first before you start with this one, so otherwise you might lose in terms of the information. Okay, so last time we have looked through what it means by point intervals, point estimate, and what it means by confidence interval in the YouTube video. So in the discussion in the YouTube video, so I have shared with you the information, and we end up the session in the video with the interval estimation for difference between two mean. Okay, difference between two mean for a large sample size for the Z test. So yang tu kita dah tengok sebelum tu. So you boleh tengok balik, refer balik pada the content in the video. So you're gonna see these things, right? So this is where the video ends. So we're gonna continue with the second case of interval estimation for difference between two means. Okay, so the second case is where we have the situation such that we have to use the t-test, the student t-test, in order to calculate the interval, okay, the confidence interval. Okay, under this case, okay, there are certain assumptions that you need to understand, so you can refer to your manual. So this is the same as the one in your manual, so boleh tengok balik. So saya just explain dekat sini what you have to do in term of understanding what the content of the manuals, right? Okay, there are certain assumptions that you need to consider before you proceed with the confidence interval for difference between two means of independent sample. And again, when I talk about independent samples, it means that you are taking sample for two different groups that is independent of each other. For example, let's say you are taking the height of male and female students from a class. So these are considered to be independent sample, because the independent means that one sample is from the male students and the second sample is from the female students, so they are independent of each other. Okay, and again the assumption that the samples are random samples, so it must be taken from a random sample. So whereby in this situation, if you want to understand more about random sample, just read through the concept on random sample from your Alan G. Blumen textbook. So it's not covered in this course. So you boleh tengok yang tu lah. Right. And then the sample data are independent of one another. Itu yang saya katakan, independent samples. And then when the sample size are less than 30. So in this situation, it is required that your sample size, if your sample size is less than 30, the population must be normally or approximately normally distributed. Otherwise, you cannot use the t-test. So you have to use the non-parametric test. Okay. So this is a very crucial assumption in order for you to use the t-test in replacement from the Z test. So dia mesti ada dalam bentuk normally or approximately normally distributed. So dia mesti ada yang ni. So it's either must be the population must be normally or approximately normally distributed, and in this situation the sample size is less than 30. Okay, the sample size is less than 30. Okay, so if for the Z test, the case one, it doesn't matter whether you have an equal variance or unequal variance. But for using the t-test to determine the difference between two means of independent sample, the first thing that you need to do is to test whether is the variance equal or not. Okay, this is the consideration whereby you have the situation such that variance are not provided, or you have an unknown variance or unknown standard deviation for both samples. All right. So in this situation, you need to test first whether is alamak. Saya nak keluar ni. Okay. Okay, whether the variance is equal or not. Okay. Before we go into detail into this one, just look back. There's one table, okay, the shortcut or not a shortcut, a cheat sheet regarding this information is available on my course website, so you can look at this one. So this is the cheat sheet yang you boleh tengok lah, you boleh download daripada website saya, website course website. So this gives you some ideas on the items that we're going to discuss before and also after this. All right. So we have discussed the previous one. We have discussed for the difference between two means. Okay, difference between two means for a large sample size. So the first one yang ni, yang atas ni. So kita dah tengok yang ni. So we look through this one last time in the video. Okay, and then we also have looked through the Z-test for small sample size whereby the sigma 1 and sigma 2 non. Okay, so saya just nak ceritakan sedikit macam mana you nak gunakan table ni untuk identify the correct items or the correct formula to be used. Okay, for difference between two means, okay, before we go detail on the previous one. Okay, for difference between two means, if you look through this one, okay, for a large sample size and also for a small sample size, as long as the variance are known, then you can use the Z-test over here. Okay, boleh gunakan Z-test. Okay, tak kira lah sama ada sample size besar ataupun kecil, provided that the population are normal or normally distributed. So kalau katakan yang ni normally distributed, is okay. Tapi kalau katakan untuk yang large sample size, it doesn't matter whether it is normal or non-normal sample size, as long as it is large sample. But for a small sample size, you require that it is the population is normally distributed or approximately normal. Okay, and in such a way that if you have the variance known, okay, both the variances known or the standard deviation known, then you can use the Z-test. The problem is that whenever you have the sigma 1 and sigma 2 unknown, so this situation, okay, situasi yang kedua ni. Okay, so in this case, you have small sample size. Okay, it can either be N1 is less than 30 or N2 is less than 30 or both is less than 30. So maknanya dia sama ada salah satu kurang dari 30 ataupun kedua-duanya kurang daripada 30, maka kita katakan dia adalah small samples. And you require that the population is normally distributed. If the sigma 1 and sigma 2 unknown, then this will be the situation. So you have two situations here. So this first situation is where you assume the variance, the population, the standard deviation is equal, ataupun the variance are equal. And the second one, we assume that the variance are unequal. Okay. So dia tak straightforward. Kalau yang sebelum ni kita terus straightforward boleh kirakan Z values, right? Tapi in this situation, to calculate the T values, you first need to assume whether it is equal variance or unequal variance. Okay. The process of identifying or to check whether the population, the samples have equal variances or unequal variances is called the Levin test. Okay, it's called the Levin test. So itu yang kita nak lihat. So that means in order to use the T statistic to determine the difference between the two means, you first need to determine whether is assumed variance or the variance are whether the variance are equal or the variance are unequal. Okay, So itu yang you kena buat dulu. So before you proceed with the next one, the next step, you need to check on this one first. You need to check the equal variances first. Then baru you boleh kira dia punya t values. And then of course, if you decide on the assumption of equal variances, the calculation will be different. The formula will be different with the one with assumed unequal variance. Okay. So yang ni kita boleh check menggunakan kaedah yang dipanggil sebagai Levin test of equal variances. Right. So kita go back to our manual. Okay, itu yang perlu kita buat dulu. So the first thing that you need to do is to check on the variances whether they are equal or not. Okay. Okay, ini dipanggil sebagai Levin test. So we call this Levin test. Okay, we call this as Levin test. So Levin test is simply testing the hypothesis of equal variances against the alternative hypothesis not equal variances. Okay. So in these situations, first you have to state the hypothesis, and then the second step is to identify or determine the alpha value. So in this case, normally the alpha value is 5% significant. So 5%. So alpha is equal to 0.05. Okay. And then check on the p-value. The third step is to check on the p-value whether do you want to support for equal variances or not equal variances. So decision here, the step 4 and 5 is the decision and conclusion, whereby you compare the p-value with the significant value alpha. Okay. If the p-value is greater than 0.05, so in this case you fail to reject H naught. Okay, and vice versa. If p-value is less than 0.05, then you reject the null hypothesis. Okay, the null hypothesis. So kalau fail to reject the null hypothesis, maknanya equal variance assumed. Okay, kalau you reject the null hypothesis, dengan kata lain, not equal variance are assumed. So once you have done this, then barulah you proceed with the next step of calculating the t values and also the confidence interval. Okay. So let's say the case here. So the case yang pertama kat sini, dia katakan confidence interval for the difference between two means, whereby, so in this situation, equal variance are equal and unknown. Okay, we assume variance are equal and unknown. So kalau katakan variance are equal and unknown, the standard error is being given by this formula. Okay, so remember, the basic information on the interval will be the parameter, okay, plus or minus the critical value times the standard error. Okay, so in this case, the parameter right now is x bar 1 minus x bar 2. Why x bar 1 minus x bar 2? Because we are calculating the difference between the two means. Sebab tu kita ada the parameter to be x bar 1 minus x bar 2. And in this situation, the critical value here will be the t statistic. So this is the critical value. Okay, so remember here the critical value is actually this part, sebenarnya bukannya t alpha over 2 only, but actually the correct way to write the critical value is t alpha over 2 with the degrees of freedom. Okay, and the degrees of freedom for equal variance assumed is given by n1 plus n2 minus 2, whereby n1 adalah sample size for the first sample and n2 is the sample size for the second sample, and then minus 2. So that means the total number of data minus 2. So that is the degrees of freedom. And then you just take the T alpha over 2. So T alpha over 2 is the same as alpha over 2 given the value of alpha. Okay. And then the difference between the equal variance assumed and unequal variance assumed will be this part so yang belakang ni, the standard error. Okay, the standard error and also the degrees of freedom. Okay, for the case of equal variances, the standard error is given by the SP times 1 square root of 1 over n1 plus 1 over n2. Okay, whereby in this situation, the SP, this is called the pool standard deviation. Okay, this is called the pool standard deviation. Okay, the pool standard deviation is given by the formula, the square root of n1 minus 1 si squared plus n2 minus 1 s2 squared divided by n1 plus n2 minus 2 divided by the degrees of freedom. Alright. So in this case, if you look through this formula, it's a bit confusing for you to memorize, right? So don't worry, because you don't have to memorize this formula, because this formula is given to you in the exam papers, right? So you just need to check on the exam past semester exam papers, look at the formula list and see what are the formula that is provided for you. Okay, you kena tengok lah formula mana yang diberikan kepada anda. Yang mana tak diberikan tu you kena kira lah, you kena hafal lah. So kalau dia dah bagi, tak payahlah hafal. You just need to know when to use it. Alright. So that is the most important part. Okay. So that is for the equal variance assumed and sigma unknown. Okay. As an example, so just look at this one. Okay, di sini dia bagi kat sini. So let's see this one. Okay, it says here, example 3.8, nowadays the nursing profession is very marketable profession in Malaysia. A government hospital normally employs nurses who have been trained from both the government and private training centers. The hospital administrator is interested to determine which training centers seem to educate its nurses better. The hospital devised a test to be given to the newly graduated nurses entering the hospital. The scores are as follows. And then in this situation, it gives you the information that equal variance assumed. So kat sini dia tak perlu kira lah. So dia dah bagi equal variance assumed. So we assume equal variance. Okay. So that means if you assume the equal variance, so you need to find the critical value and the standard error using the formula as we mentioned earlier. Okay, so you need to obtain a 90% confidence interval for the given information. So you have this data. So you have government ada 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then for the private sectors candidate, you have 13. So both of these is less than 30, right? So in this case, you can see that N1 is less than 30 and N2 also less than 30. Okay, and then we assume that both come from a normal distribution. Okay, we assume that both come from a normal distribution. So in this case, you cannot use z-test. So here, since the sample size is small and the variance are unknown, or the standard deviation are unknown, the population standard deviation are unknown, so that means you cannot use z-test. So you need to use the t-test. And of course, the t-test you need to understand whether you need to determine whether equal variance assumed or equal variance not assumed. In this example, it's already mentioned that equal variance assumed. Okay. So given the formula, given the output for the score test, you get the value for the mean and also for the standard deviation and the standard error. Okay, so remember the standard error is basically we are not going to use this one because you need to recalculate the standard error. So from this information, you know that the value of mean x1 minus x bar will be 84.82 minus 85.15 or vice versa. Okay, ataupun sebaliknya. So depending lah macam mana you nak buat. So in this situation, you have the degrees of freedom to be n1 plus n2 minus 2. That is 11 plus 13 minus 2. So you get it to be equal to 22. And calculating the full standard deviation, you get SP equal to 9.698. Okay. And then from here, you can calculate the value for the interval. So here, x1 bar minus x2 bar, we'll just take the mean value. Okay, tadi mean kita adalah these two values. So you have 84.282 and this one. Okay, so this will be the x bar 1 and this will be the x bar 2. Okay. So calculating this value, so you get x bar 1 is 84.82 minus 85.15, and then you calculate the SP to be 9.698, and the standard square root of 1 over n1 plus 1 over n2, you get 0.410. Okay, and then the T alpha over 2, so this one is actually, so this supposed to be T alpha kita 0.1 kan. So 0.1 divided by 2 with degrees of freedom is 22. Okay. So that means in this case, this part you get T 0.0522. So how to get this value? So macam mana dapat 1.717 ni? So you have to look at the distribution table. So looking at the distribution table, so this one is chi-square, so you nak chi yang student T. So this will be the student T. Okay, so this will be the student T punya table. So you have alpha over the and degrees of freedom. Your alpha sekarang ni, tadi 0.1, bila alpha divided by 2, you get 0.05. So you have to look at 0.05. So this ni so the second part here. So you have to look over here. Okay, tengok kolom 0.05. Bukan tengok 0.1, walaupun diberi alpha sama 0.1, but this one is a one tail punya diagram. So you tengok dia menyelorikan tu sebelah saja. So you kena ambil alpha. So in this situation, kalau tengok kita punya formula tadi, kita punya alpha ni adalah 0.05. So this refer to the alpha in table. Okay, bukan alpha dalam soalan. So alpha in table. So this one you tengok alpha in table. So tengok balik kita punya table, tengok kita nakkan alpha sama 0.05. So the second column, and then the degrees of freedom is 22. So you scroll sampai dapat 22. So here you get 22, and then the value for the second column is 1.717. So that's why kita dapat kat sini 1.717. Okay. So once you have substitute the values in here, so just calculate evaluate the equation. So you get the confidence interval to be between -7.157 and 6.497. Okay, so that is the situation. So in this situation, kalau ditanyakan, is there exist any difference between the two means? Ada perbezaan tak antara kedua-dua nilai mean sample tadi? So di sini jawapannya tiada perbezaan. Okay, there is no difference. Okay, with 90% confidence, there is no difference on the number of newly graduates, nurses, entering hospital between government and private sector. Why? Because the zero value is not included in the interval. Kenapa kita akan zero value ni tak included? So remember, for this part, bila kita nak test for differences, our H0, our null hypothesis is that mu1 is equal to mu2. Against our alternative hypothesis is mu1 is not equal to mu2. So kalau you perhatikan dekat sini, mana dia? Okay, kalau kita perhatikan kat sini, if you look through this one, let me get my color. Okay, this part so kita tengok ini. So H1 ni, so this H1 can also be written as mu1 minus mu2 equal to 0. Okay. So that means kalau katakan kita nak katakan bahawa ianya adalah sama, tiada perbezaan antara mu1 dengan mu2, dia mesti bersamaan dengan kosong. Okay, so untuk test sama ada dia berbeza atau tidak, that is why the reason we look into whether 0 is included in the confidence interval or not. If 0 is included in the confidence interval, meaning to say that we fail to reject the null hypothesis. So in this situation, 0 is included in the confidence interval. Sebab kalau kita kat sini, if you draw this in a real number system, you have negative 7 over here, 0.157, and then you have 6.497. And where does 0 lie? So 0 ada dekat sini. So 0 is over here. So you have 0 over here. So 0 is included in these two area. Okay, these two values. So 0 tu berada di tengah-tengah. Dengan kata lain, dia tiada perbezaan. We fail to reject the null hypothesis. So we conclude that there is no difference on the number of newly graduates nurses entering hospital between the government and the private sector. So this will be your conclusion. So yang atas ni adalah you punya conclusion. Yang ni adalah you punya reason. So this is conclusion. And this will be your reasons why. Okay, reason to support your conclusion. Okay, any questions so far? Boleh so ada soalan Right. Okay. So boleh. So any questions so far? Boleh? Boleh. Alright. So let's continue. Ada soalan tak? Tak ada Boleh Alright. So kita continue dengan the next one. Oh, sorry. Okay. Tadi case di mana kita ada equal variances. Okay. The second one is the case whereby you have unequal variances and unknown. And at the same time, the sample size is small. Okay, small sample size with unequal variances and unknown. Okay, unknown variances and unequal. So process the same, will be the same process as before. The only difference is that the calculation of the degrees of freedom and also the standard error. Okay, the calculation of the degrees of freedom and the standard error. So that will be the difference. Elok lagi itu. Alright. So this is the given information on the calculation of the degrees of freedom and the standard error. So again, as I mentioned earlier, the first thing that you need to do is to determine whether you have equal variances or unequal variances. Alright. So kalau kita dah tahu bahawa ianya adalah unequal variances, so you need to use this formula. Okay, kena guna formula ni lah. So macam mana kita nak gunakan formula ni? The only difference dengan yang tadi tu sebelum tu adalah dari segi pengiraan dengan degrees of freedom. Whereby previously the degrees of freedom is simply n1 plus n2 minus 2. Right? But right now, the degrees of freedom is a bit complicated, whereby you have to calculate using this formula. Again, you don't have to memorize this formula because this formula is given to you in the exam. Okay, jangan pening-pening kepala untuk memorize all this formula. You are not a statistician yang perlu memorize all these things. You all adalah the end user. So end user kita just apply apa yang kita dapat. Alright. So this is the calculation of the degrees of freedom. Cuma jangan make sure lah you calculate it correctly. If the given information, if the given formula have to be used, then make sure you use it correctly. Sebab sometimes student make mistake in term of copy the right formula. Okay, copying the right formula. Formula dah bagi, tapi bila dia copy masuk dia punya kertas jawapan, tersalah copy and then tersalah masuk nilai. Itu yang jadi masalah. Okay. So you have the formula given by SI squared N1 S2 squared N2. Kenapa dia gunakan S dekat sini? Because this one is based on the sample. Okay, this is based on the sample. Dia tak gunakan daripada populasi, dia tak gunakan sigma. Kalau gunakan sigma, maknanya kita dah tahu populasi. So tak kisahlah size sample besar ke kecil, kita boleh gunakan Z test. Tapi yang ni kita tidak ada variance untuk populasi, so you estimate from the sample. That is why kita gunakan simbol S rather than using sigma. Okay, kena faham betul-betul eh. Yang lain tu semua sama je. So again, this one supposed to be this part eh. So this part supposed to be T alpha over 2 and the degrees of freedom eh. So itu the correct way of writing the critical value. So dia mesti ada the degrees of freedom. Dia berbeza dengan Z sebab Z tak ada degrees of freedom, just Z alpha over 2. But for T statistic, you must have the degrees of freedom attached to the critical value. Okay. So this is the situation. So in this case, kita tengok one example macam mana pengiraan dia. Okay, it says here a researcher wishes to see if the average weight of newborn male infants are different from the average weight of newborn female infants. Okay, dia nak tengok perbezaan. Ada tak perbezaan berat bagi bayi lelaki yang baru lahir dengan bayi perempuan yang baru lahir? Ada tak perbezaan berat? So kat sini dia select a random sample of 10 male infants dan dia kira dapatkan dia punya mean weight 123 ounces. And then untuk yang dia punya standard deviation is given by 8 ounce. So in this case, daripada sini, from this information, okay, so this give you the information for the male infants. And then for the female infants, you get mean weight of the 8 female infants. So that the 8 female infant and weight here with the standard deviations. Okay. So yang ni adalah untuk mean, untuk female So yang ni untuk male. Okay. So basically from here you get untuk male X bar equal to 123 and then S equal to 8 and then N equal to 10. And then for female, so you have X bar equal to 116 and then S is equal to 5 and N is equal to 8. Okay, so the question right now you want to test, you want to check whether is there any difference between the mean weight of male and female infants. Okay, so nak tengok ada perbezaan ke tak So di sini kita nak gunakan confidence interval untuk tunjukkan sama ada perbezaan ataupun tidak. And in this situation, we assume that equal variance is not assumed. Okay, kita punya assumption adalah equal variance are not equal. Okay, so equal variance are not equal. Alright, so kita nakkan 95% confidence. So that means in this case, alpha is equal to 5%. So which means that alpha over 2 is equal to 0.025. Okay, so in this situation, you need to find t 0.025 with the degrees of freedoms. And the degrees of freedom is given by these formulas. You get it to be 15, right? Okay. So what to do next is to look at the table and locate the value for the degrees of freedom and also the alpha values untuk dapatkan nilai critical value T. So tengok balik table ni. So nakkan 15 and then for 0.025, so it will be in the third column. Okay, third column So tengok dekat third column 15, so you get 2.131. So that's why in this case you have the value to be 2.131 over here. Okay, and then x bar 1 minus x bar 2 dapat mana? So dapat daripada nilai 1, 2, 3 tolak dengan 1, 2, 6 So this one is 1, 2, 3 minus 1, 1, 6. So give you 7. Okay. And then S1 is simply, so this ni S1 dia adalah S1 squared. So this part, okay, this become, you akan dapat the square root of S1 squared. So S1 squared is 8 So 8 kuasa 2 bahagi dengan 10 tambah dengan 5 kuasa 2 bahagi dengan 8. Okay. So this will give you this value 3.086. And calculate the interval. You get the interval to be 0.4 until 13.5. So look at the interval. Is 0 included in the interval? The answer is no, right? So there is no 0 in the interval because 0 is outside of the interval. So kalau kita lukiskan gambaran kat sini, so we have 0 over here and then we have 0.424 over here and then you have 13.576. Okay, so that means since 0 is not included in the confidence interval, you can conclude that there is a difference. So there is enough evidence to conclude that the mean weight of male and female infant is significantly different because 0 value is not included in the interval. So you have your conclusion saying that they are different. And the reason is that because 0 is not included in your interval, confidence interval with 95% confidence. Okay, so that is for the second situation. Alright, so any questions so far? Okay, let's, yes saya. Ya, betul. So, kalau kita nak tengok sama ada, sebab persoalan sekarang ni, soalan tu tanya, adakah perbezaan antara berat bayi lelaki dengan bayi perempuan? Okey, ada perbezaan ke tak? Berat bayi lelaki dengan bayi perempuan semasa lahir. So, kat sini kita nak tengok kalau dia ada perbezaan, kalau katakan nilai itu kosong, berada dalam dia punya confidence interval, bermakna tiada perbezaan. Sebab bila kita ambil berat bayi lelaki tolak dengan berat bayi perempuan, kalau dia tiada perbezaan, dia akan jadi kosong lah kan? Betul tak? Katakan bayi lelaki tu berat dia 8 kilo. 8 kilo pula bayi beratnya. 3 kilo lah, 3 kilo. Yang perempuan pun berat 3 kilo. So, tak ada beza kan? So, bila tak ada beza, kita tolak berat lelaki dengan perempuan, tolak jadi kosong. So, kalau nilai dia kosong, maknanya tiada perbezaan. Sebab itulah kita gunakan kosong tu sebagai indikator untuk kita tentukan sama ada perbezaan ataupun tidak. Kalau dalam confidence interval tersebut mengandungi nilai kosong, maka tiada perbezaan. Tapi kalau dalam confidence interval tersebut tidak ada nilai kosong, bermakna dia berbeza. Okey, macam contoh yang ni, 0.424 ni dengan 13.576, nilai kosong tak ada dalam kawasan ni. So, maknanya ada perbezaan. So, nak tahu sama ada nilai kosong tu ada dalam tu ke tak, tengok dari segi dia punya sign. Kalau satu positif, satu negatif, of course, 0 is included in the interval. Tapi kalau kedua-duanya negatif ataupun kedua-duanya positif, of course 0 will not be included in the interval. Senang, mudah nak faham. Kan? So in this case, kita tengok kosong tu as an indicator nak tentukan keputusan adakah perbezaan ataupun tiada perbezaan. Boleh? Faham ya? Alright. So that is if you are given in the form of a manual calculation. So dia bagi tu, you kena buat calculation. So bagaimana kita nak tengok jawapan daripada output contohnya. Macam mana kita nak baca jawapan daripada output. So example 310 ni memberikan anda satu contoh bagaimana kita nak membaca output dan menjawab soalan yang ditanya. So consider this example. We have the carbohydrate in candies and then the number of gram of carbohydrate contained in 1 gram serving of randomly selected chocolate and non-chocolate candy. So we are considering right now, we are looking at is there any difference of carbohydrate content in chocolate and non-chocolate candy. Okay, so based on the 90% confidence interval, is there significant evidence to conclude that the difference in mean is statistically significant. Maksudnya kat sini, dia katakan difference in mean. So maksudnya, difference, the content of carbohydrate in chocolate, okay, the mean content of carbohydrate in chocolate and non-chocolate candy, do they differ or not? Okay, do they differ or not? So sebab tu kita ada dua sini, satu chocolate dan satu lagi non-chocolate. So kita ada kat sini, yang the first one, group 1 ni, so this one refer kepada yang chocolate. And then yang nombor 2 ni, this one refer kepada non-chocolate. Okay, macam mana saya tahu chocolate dengan non-chocolate? Sebab tengok dia punya bilangan data lah. So yang ni ada 13, yang ni ada 11. So of course yang chocolate ni lebih banyak kan. And here from the table output, so this output is obtained from the SPSS. So this output is given from the SPSS punya table. So you have two tables over here. One is the descriptive statistic that give you the information on the descriptive information. Okay, descriptive statistic, whereby it gives you the mean value for both groups and also the sample size for both groups together with the standard deviation and the standard error of the mean. Okay, dia ada duduk. So this one is S, this one is SE. So jangan beza kedua-dua ni. So jangan confuse dengan dua ni. So the one is standard deviation, the other one is standard error of the mean. So apa maksud standard error of the mean? So this one is basically S divided by the square root of N. This one just simply S saja. Okay. Itu beza ya. So standard error of the mean dengan standard deviation. Okay. So this info give you the X1 bar and X2 bar. Okay, macam mana kita nak tentukan? Okay, apa pula yang second table ni bagi tahu anda? Okay, the second table give you the information on whether to assume equal or unequal variance and how to read the table based on the information on the Levin test. Okay, dia ada dua row kat sini. So, bila ada dua row kat sini, you kena tentukanlah row mana yang you nak baca. Okay, jawapan anda. Okay, first of all, you need to read through the Levin test. Okay, sebab apa kita perlu dapatkan Levin test ni? Kita tengok kat Levin test ni dulu. So, Levin test ni untuk test whether you have equal or unequal variances. Okay, what to look here? So first thing that you need to do is to look at the significant value. Okay, significant value. Okay, sebab the significant value will be used in order to determine whether you need to reject the null hypothesis for equal variance or fail to reject the null hypothesis for equal variance. So the Levin test will test H naught sigma 1 squared equal to sigma 2 squared. So in this case, equal variance. Variance are equal, and against the alternative unequal variance. So kita nak tengok yang mana satu. So look at the significant value, determine your alpha level. So in this situation, your alpha is 0.05 and your significant value is 0.189. Okay, the significant value is 0.189 ataupun p value. So significant value dengan p value ni adalah benda yang samalah. So apa benda p value ni? P value ni apa pula kan? Sebenarnya p value ni adalah singkatan untuk probability value. Okay, probability value. So the p value is 0.189. You check whether is 0.189 greater than or less than 0.05. Okay, sekarang ni yang mana satu? So adakah dia lebih besar ataupun dia lebih kecil? So of course dia lebih besar kan? So kalau lebih besar, you fail to reject the null hypothesis. Okay. If the p-value is less than 0.05, if p-value less than alpha, here you reject H naught. Okay, here you reject the H naught. But in this situation right now, the p-value is greater than alpha. Okay, so greater than alpha, meaning to say that you fail to reject the null hypothesis. So you conclude the null hypothesis and say that the equivariance is assumed. Kenapa perlunya kita tentukan equivariance assume ataupun tidak? Sebab kita nak tentukan, bila kita tengok dia punya Levin test, dah tentukan bahawa equivariance assume. So dia ada dua row kat sini. Satu, first row is for equal variance assume. The second row is equal variances not assumed. So this will determine whether you have to read the first row or the second row. So in this situation, since equal variance assume, so you akan gunakan this part untuk baca result. Tapi kalau this value is less than 0.05, then you have to reject the null hypothesis and conclude that equal variances not assumed. So you kena baca row yang kedua. So result you daripada menggunakan row yang kedua. Okay. So what next? Next, once you have determined your variance, equal variances assume or not assume, then you look at the t statistic here to determine whether is there any difference or not. So bila kita nak test, yang ni kita akan go further in the next chapter. But here saya just terangkanlah. So you ada dua cara, you ada beberapa cara untuk you tentukan. Ada tiga cara sebenarnya untuk you test hypothesis sama ada reject or fail to reject. So one is by using the p-value. Okay, tengok dekat p-value ni and compare with the significant alpha level 0.05. Again, if it is less than 0.05, you reject the null hypothesis. If not, you fail to reject the null hypothesis. The second one is by using the t critical value here. Compare this t value with the critical value obtained from the table. Okay, so this is the calculated t value. You compare dengan critical value from table. Okay, and then you boleh tentukan sama ada nak reject ataupun tak reject null hypothesis. Okay, yang ni pun akan dibincangkan dalam chapter yang akan datang. Yang kita bincangkan sekarang adalah dengan penggunaan confidence interval. Okay, so kat sini daripada maklumat di sini, you boleh kira lah you punya confidence interval. So bila you kira confidence interval, you dapatlah nilai-nilai ni semua. Dapat balik nilai tadi lah. So mana nak cari nilai-nilai ni? So negative 4.671 ni datang daripada mana? So datang daripada table. Okay, this one So this is x bar 1 minus x bar 2. Okay, this will be the standard error of x bar 1 minus x bar 2. Okay, so gantikan sajalah. Alright. So again macam saya katakan tadi, sebelum ni kita punya theta plus minus T alpha over 2 degrees of freedom and then multiply with the standard error, right? So theta yang ni lah. So theta kat sini, so 4.671 negative 4.671 and then SE kita adalah 3.666 and this part kita dapatkan daripada table, so we get the value to be 1.717. Calculate everything, you get this value. So right now determine ada perbezaan ke tak? So what is your conclusion here? So kita tengok kat sini, ada kosong tak dalam ni? Ada kosong kan? Sebab dia ada perubahan tanda, negatif dengan positif. Kalau dua-dua negatif, that means there is zero is not included. Ataupun dua-dua positif, zero is not included in the confidence interval. Right now, one is negative, the other one is positive. So that means zero is in the confidence interval, meaning to say that there is no significant difference between the of carbohydrate contents in chocolate and non-chocolate candy. Sebab tu kata kat sini, with 90% confidence, there is no significant difference. So, kita kata no significant difference on the number of gram of carbohydrate contained in chocolate and non-chocolate candy. Because why? Because zero is included in the interval. Okay, so that is for the second case for the T statistic for independent sample. Okay, ada soalan so far? Any questions so far? Tak ada Boleh Okay. The last part in this chapter will be the dependent sample. Okay, tadi kita tengok independent sample. Yang ni kita guna kelak dependent sample. Okay. Kalau dalam SPSS, kita panggil ni sebagai PET sample t-test. Yang sebelum ni kita panggil sebagai independent sample t-test. Kalau yang awal mula-mula tu dalam yang saya bincangkan dalam video tu adalah one sample t-test. Okay, dia ada one sample. Kita ada independent sample. And kita ada PET sample. Ataupun PET t-test. Okay, so this is the t-test yang kita bincangkan dalam kita punya syllabus. Alright. So the next one, the last one under this topic will be the dependent sample, meaning to say that the sample come or the score come from the same population ataupun from the same population, from the same object. Contohnya katakan saya ambil score before and after. Okay, ataupun kita ambil weight of a person before entering a gym and 1 month after entering a gym. Okay, sebulan sebelum dia masuk gym untuk exercise dengan weight dia sebulan selepas dia masuk gym untuk exercise. So kita nak tengok sama ada perbezaan ataupun tidak, ada improvement ataupun tidak. Okay, so in this case, this is what I mean by dependent sample, because the score, the items or the recorded data is collected from the same object. Okay, from the same object. So again, in this case, you don't have to worry about the formula because the formula is given to you in the exam. You just need to know when to use it, how to use it. So this is given by this formula. Mu D ni refer kepada difference. So it can be before and after, pre and post. Okay, before, after, pre and post ataupun sebaliknya. Okay, before treatment, after treatment, 1 month earlier, 1 month after. So it depends, right? So depends on the situation. And then mu D ni adalah dia punya difference for before and after tadi. So maksudnya kat sini mu D will be, contohnya mu D, one example, mu D ni can be X bar before minus X bar after. Contoh. Ataupun X bar pre dengan minus X bar post. Okay, pre and post. Boleh juga So that is D. Okay, mu D. So this one adalah mu D. Sebelum yang ni kita akan dapat ini So D ni refer kepada this one So this refer to this part Kita gunakan sample So we have a X bar before. And of course kalau yang mu D ni kita gunakan mu lah. So mu 1 minus mu 2 lah biasanya Ataupun mu before minus mu after. Okay. So yang lain-lain tu semua sama. Cuma yang berbeza dekat sini dia punya standard deviation dengan dia punya pengiraan standard error. So the n value here. So in this case, n here refer the degrees of freedom. Okay, refer to n minus 1. So n minus 1 ni refer kepada n ni refer kepada number of pairs. Okay, dia mesti pair yang sama So dia mesti ada, kalau ada before mesti ada nilai untuk after. So dia tak boleh tak ada yang tak ada yang missing So dia tak boleh missing. Dia mesti in pairing. Okay, dia mesti dalam bentuk pair. So mesti ada 2 macam tu. Okay, setiap satu tu mesti ada 2 data. Alright, before and after, pre and post. Mesti ada. Alright, so that's why in this case, n, okay, yang ni kena berhati-hati. Kalau sebelum ni, n tu semua adalah melibatkan size sample. N1, N2. Tapi kat sini, n ni refer kepada size pair. Okay, berapa number of pair yang ada. Okay, so dia punya size dalam bentuk pairing So, n minus 1. And SD ni adalah dia punya standard deviation. So, macam mana standard deviation ni? So, of course, kalau katakan kita ada X1 and then kita ada bukan X1 So, suppose you have before and then you have after. And then after this, you adalah nilai-nilai dia kan. So, dia ada nilai semua. And then you kira dia punya difference. Okay, you kira dia punya difference. So, from here, you can calculate the difference. So, you dapat dia punya difference. So, daripada sini, you boleh dapatkan dia punya average D bar. Okay, D bar ni adalah dia punya average. So, you kira difference dahulu and then baru dah kira dia punya average. So, daripada average ni, daripada sini juga, you boleh dapatkan dia punya standard deviation. Okay, of D bar. Okay, macam mana nak kira ni? Sama macam kita kira standard deviation dalam chapter yang kedua. Okay, sama je. So, sama dengan kita kira. Cuma sekarang ni, dia punya data kita ambil dia punya difference dulu. So, we take the difference first and then kita kira D dengan D bar dengan SD bar. So, kita assume that this one is your actual data. Okay. So, let's look at the example 3.11. Macam mana dikira Okay. So, you have two data over here. So, this one is 3 years ago and today. So, this is the sample of 9 local banks. So, that means in this case, n is equal to 9. So, the degrees of freedom here will be 9 minus 1, that is equal to 8. Okay, the degrees of freedom will be 8. So, you have 9 banks over here and then you have the scoring 3 years ago and today. So, before and after. Alright. So, the next thing to do is to calculate the difference. Okay, yang ni dia bagi contoh tu So, kalau saya nak kirakan dia punya ni secara manual. Okay, let me calculate this manually. So saya nak buat kat mana? Macam mana nak buat manual? Okay, tak apa. Saya boleh buat macam ni. Saya tunjuk dekat atas ni. So you boleh try kira this one. Balik nanti boleh try kira. So you have to calculate the difference first. So here you calculate the difference. So take the difference of these two. Contohnya 11.42 minus 16.69. Okay, so you akan dapatlah 11.42. Okay, saya ambil calculator saya. Okay, 11.42 minus 16.69. Okay, so you akan dapat ni sama juga dengan negatif 5.27. So you akan dapat ni negatif 5.27. So you will do the same thing over here. Okay, and then you akan kira dia punya D square. Kenapa nak kira dia punya D square? Ataupun you boleh kira dulu dia punya D bar kat sini. So kat sini ujung boleh dapatkan D bar sama juga dengan summation of D divided by 9. So you akan dapat D kat sini. And then bolehlah you kirakan dia punya perbezaan. Okay, sama ada you kirakan D squared ataupun or you can calculate the D minus D bar. Dapatkan nilai dekat sini and then squarekan dia. Dapatlah kat sini boleh dapatkan D minus D bar square. And then barulah you kira dia punya standard deviation. Okay, yang tu you boleh tengok, boleh rujuk dalam buku Alan G. Blumen. Ada ditunjukkan So you check on the Alan G. Blumen. Dia ada tunjukkan detail macam mana pengiraan. Saya tak ingat buku surat berapa So nanti you check balik So Alan G. Blumen. Buku surat berapa pun saya tak pasti So adalah dalam tu So dikirakan secara manual. Tapi apa yang kita nak lihat kat sini adalah yang menggunakan output. So macam mana kita baca output dia? Okay, suppose that you get this information. So this is pet sample statistic ataupun pet sample t-test. So the first table here give you the descriptive information sama macam yang sebelum ni. Okay, kita ada yang 3 years ago. So this is the mean for 3 years ago and then the mean for today. And then you have the number of samples. So in this case, the pairing is 9. So both have 9 values. And then you have the standard deviation and the standard error of the mean. So the same thing. To get the standard error of the mean for each of the group, just take the standard deviation divided by the square root of n. Okay. So you get this value. And then you have here 3 years ago, the pet sample test result. You have the mean. So sometimes in the exam, they make it blank over here. And then they ask you find the value, the blank value here. Berapa nilai kat sini? So apa yang perlu you buat? Just take 4.2011 minus 5.2822. So dapatlah 1.0811 ni. Okay. So this is basically 4.2011 minus 5.2822. Okay. And then the standard deviation here, yang ni dapat daripada mana? Yang ni you tak boleh kira directly daripada sini. So yang ni memang kena kira secara manual lah. Kalau katakan data tu ada. So you can just get it by manual calculation. Okay, so there is no way untuk dapatkan ni secara daripada table lah. Sebab ni dia kira secara berasingan. And then of course the standard error of the mean, just simply take the standard deviation divided by the number of samples. So kalau tengok yang ni, kita akan dapat lah. So 1.93728 divided by square root of 9. Okay, you akan dapat 0.64576 sama dengan yang tu lah. Okay, sama dengan ni. So yang ni just take simply, this one just simply 1.93728 0.28 divided by the square root of 9. Okay, so this is the same as this value. So you akan dapat lah. So this value adalah sama dengan nilai yang ni. So you boleh kira secara manual ataupun tidak. So this one is ST divided by square root of n. And then this is the value of the mean difference. And then where does this value comes in? 2.306 ni datang daripada mana? Because you are using 90%, right? Okay, you are using 90%, so that means, 90% 90 ke 95 95%, so 95%. So that means this value is actually, this is the value of t, 95%, so that means 0.025 degrees of freedom, and minus 1, that is 8. Okay, so you akan dapat 2.306. So macam nak tengok, so tengok balik dekat table T, 0.025 and then 8. So you get 2.306. Alright, so you get this value 2.306. Okay, so you dapat 2.306. Okay, so substitute the values in the formula. You get the interval to be between -2.57 and 0.408. So in this situation, kalau you perhatikan, nilai dia adalah antara -2.57 dengan 0.408. Okay, so 0 is here. So 0 is here. Okay, so that means 0 is in the interval. Meaning to say, kalau dalam jawapan tu, nilai kosong berada di antara nilai confidence interval. So we fail to reject the null hypothesis, saying that there is no difference between before and after between the pair. So in this case, with 95% confidence, there is no difference. Okay, there is not enough difference or not enough evidence to conclude that the average in deposit for the bank today and 3 years ago differ. Okay, so there is no difference. So dia punya deposit 3 tahun yang lepas dengan sekarang adalah kekal sama. Sebab nilai kosong berada di dalam confidence interval tersebut. Okay, so that is for the PET sample t-test and how you get it from the tables. Alright, so ini adalah satu lagi contoh so boleh tengoklah. Okay, yang ni contoh yang mana dia katakan ada tiada perbezaan juga so dia akan dapat. Okay, any questions so far? Boleh?